Hi, good afternoon. I hope the coffee break was refreshing. We can still open the windows if we have to. So, who didn't see the presentation yesterday from Angel? Or everyone saw it? Okay, cool. For those who didn't, I have like literally 2 slides that summarizes it. So, very quickly about me. I'm Vlad Trifa. My background is computer science. I studied at EPFL for my master, robotics, machine learning. Then did my PhD here at ETH on the Web of Things. So Web of Things is how to use web technologies and standards for the Internet of Things. So REST APIs, JSON, all those things so you can program physical devices with in the same way that you program websites. I've been a researcher in a few other places, always on this topic of Web of Things. I wrote a book about it last year with Dominic, who was my co-founder at Web of Things. I had a startup in the space, launched a digital lab at Swisscom, recently at EPFL, and now joined back the startup world because I think that's where stuff is happening. Nothing wrong about enterprises, but it's different. Good, so that was me. Very quickly about Ambrosus. What exactly are we trying to do? So we're trying to use technology essentially to ensure product trust in a very complex world, and especially applied in context of food or pharmaceuticals. The biggest and one of the most important problems is counterfeiting. Not just because that means loss of revenue, but because there are health problems. If you buy a fake drink like this, which is made with very dubious ingredients, you might run into trouble, obviously from a health safety. The second aspect is product quality. How do you know exactly what's in there? How do you know there are no harmful chemicals or some weird untested substance? How do you have this guarantee? The third aspect as well is trustability. What's the story of this bottle when it was made? How did it came to be on this table at LTH? How was the water transported? And all those aspects. And once you start gathering data about what happens in your supply chain, about all those aspects, as a very nice side effect, you can start looking at optimizing the supply chain efficiency. How do you make it cheaper, faster, more convenient, more pragmatic to ship products across the world and guaranteeing this. So what we do as a company is really, we're building essentially a blockchain-based solution, an end-to-end ecosystem to ensure the authenticity, quality, and origin of pharmaceutical products and other very sensitive ingredients. And we have 4 main ingredients. The first one is the data storage, and that's really how do we store data with high integrity? How do you trust the data is stored? How do you know no one is going to mess around with it? And number 1 is essentially a big chunk of what I will be presenting afterwards, how exactly it works. The second aspect is, okay, you have a place to store data, but how do you collect that data? How do you trust the data that you're putting in the system in the first place? How do you know no one is messing around with sensors or the communication between the sensors and the data management system? Then once you have trusted data that you collect and you can share, then comes the most interesting aspect, is how to use that data to build new, very interesting types of applications. How do you build new apps that squeeze out value of those products? And finally, how do you build some very specific applications on top of the ecosystem? Say someone is exporting sake from Japan and they need to apply some very specific regulations around their product. How can they come to Ambrosus and very quickly build a sake-specific application that guarantees the authenticity and traceability of the sake, and they can essentially resell that application or monetize it further. So, before we jump into the details, essentially the core of the software part at Ambrosus is what we call AmbNet. It's Ambrosus Network. And what it does essentially is a decentralized software infrastructure, as you will see on the next slide, that allows us to collect data from literally every step of a product. We can follow the product, where it was, how it was transformed, what ingredients it was made with, and I'll show you how to do that in a minute. And the point of having all that data, as I mentioned, is you can start building your applications, track and trace, compliance, maybe insurance of transportation, and so on. Now, just one step further, how Ambrosus really looks like is you have a distributed network here, where you have different nodes. They all have the same view of products. So if one node says here, okay, I've created a batch of 10,000 products like this one, and this is their individual IDs, then all the other nodes in the network will record that information and know, okay, well, this ID belongs to a BIOTS, VIVIS, which is the green tea flavor. And that information gets recorded in a very transparent and non-mutable way in the network. But on top of that, you can easily connect physical equipment, hardware, sensors, or even RFID tag to one or other nodes in the network. And I'll show you as well in a minute. And you can imagine having a printer. Every time that printer prints one label that you put on your product, especially if it has a unique serial number, like a QR code, for example, every time that printer records it, he will say to the network, hey, I've printed this. So there's no other ways of creating new barcodes without the network knowing about. And that's how you guarantee exactly how many products you've made, how many of them you've shipped, and that's how you follow the product throughout its life. Likewise, you can have a barcode reader or an RFID scanner, which is this element here. This is a handheld Bluetooth that you can connect to your phone, and you can talk to the network and say, okay, I've just found this RFID tag, or I just found this ID. Dear network, tell me what that product is about. Give me information about that product so that you can use it in a logistics space. The third element is obviously here sensors, and this is very interesting because if I send you a box of days or a big pallet of days, and for some reason this needs to be conserved under 5 degrees because it's made out of milk, it's not, but it could be. And if it's made out of milk, you want to guarantee that the temperature has been conserved throughout the shipment, so you can attach some sensor either to the product or to the box that's transporting the product, so you can prove that the temperature, the humidity hasn't been exceeded. And we'll show that if we have time in a minute, how exactly to implement that with Ambrosus and with using smart contracts. The last element is obviously data sharing. How do you collect, how do you create applications that can be a mobile app that you can just use. It's a very simple native app, that's something you can build on Ambrosus. You can create a more complex dashboard. So if you're a company here and you want to visualize all your products in the market, how they move, you can use, for example, machine learning to detect if this product is being sold at another shop and not the one it was supposed to, or in another country. This is a big problem. That's called gray market. That happens a lot in the alcohol industry or cigarettes, where you buy cigarettes in a country where they're cheap, you resell in another country where they're expensive, and you make a lot of margin. And obviously product manufacturers are very unhappy about that. And if you can collect all the real-time information about each one of your products, then you can very easily detect where counterfeiting happens, in which country, who are the distributors who are actually copying or reselling your product in the wrong place. And that's a very interesting business opportunity that we're exploring. Now, just coming back to the hackathon and what we want to focus. So we propose a challenge that we invite everyone to give it a shot, is in the context of pharmaceutical industry, and it's a very real problem many pharmaceutical companies have. And essentially we'll focus on the manufacturers, so pharma company who manufactures medicine, drugs, and how they work with their suppliers. And we really focus on using blockchain. How can you use blockchain? How can you use the Internet of Things to digitalize, trace what's happening between those two, and how do you increase the efficiency? And I'll get to the exact problem in a second, but imagine the scenario. You have the pharmaceutical company. They order 500 liters of glycol. It's one of those big containers, and they use that to manufacture tablets, for example, from a supplier. So, I mean, there are very important questions that they ask, and that's kind of the reality today. Where is my glycol? When will it arrive? Has it been transported at the right temperature? More interestingly, well, what if my order arrives a few hours late or a few days late? And even worse, how do you know if it's been spoiled? And what happens if one of those things, if the product is late, who gets paid? Now, the reality how it works in the pharma is they have, of course, contracts that say, yeah, if you come here, if you're delayed, then you have to pay a penalty and so on. But this is the theory, and yeah, of course, you can go to court and bring your big suppliers and say, hey, you need to pay me back. but that takes a lot of time, a lot of money, and often it's not really worth it. So the very interesting opportunity here is to say, well, what if you use a smart contract to automatically calculate if your product arrives on time in the right condition, and if not, automatically get paid or receive a penalty using cryptocurrencies, for example. And that's a very interesting use case because that happens a lot of the time from pharma. They lose a lot of time, and every hour of delay on a pharma line means like thousands, hundreds of thousands, millions of dollars. So if you can optimize and reduce the impact and the penalty and the cost when you have a problem in your supply chain with blockchain technology, that would be really cool. So that's essentially the challenge we're inviting you to explore how to do that. We'll give you some source code and some stuff to get started. I mean, that's what I'll present just after. But I think there are lots of very interesting opportunities to play around with that. I'm going to be here for the rest of the week hackathon, so if you have any questions or if you want to get to learn more the Ambrosus API, you can always reach out. So now let's get to the nitty-gritty how exactly that works. So of course I mentioned we're a blockchain-based company, but to make it very convenient, one of the things we built, and that's something you might have seen in the previous presentation, is that we used a gateway that allows you very easily to use web requests, and that's something what you've seen with Web3 in the presentation earlier. One thing you can do is essentially you have a local gateway. We have built one in the cloud, and that's what I'm going to show you how to use in a minute. But essentially what that gateway does is it provides you a web API that you can very easily start programming, and in the back that data, the data you're sending to that API can either get stored locally in the cloud, so it's just a SaaS if you just consider that part of the equation, but then you can write some events and some other information on either Ethereum, IPFS, or to other nodes in the Ambrosus network. Now, if we get to that, the real value of that is you can very quickly get started and build some prototypes without having to learn the specifics of Ethereum and IPFS, but you can have access to that. So, the very simple, let's get started, that's what I would say. So, the very simple way, you have the easy way, which you can go to a dashboard. By the way, what you're seeing here, no one has literally seen it because we released that alpha like a week ago, and no one has been playing around with it other than us. So it's a lot of under construction, but we'd really love your feedback, your thoughts, see stuff that's working, if you have any questions, if you have any suggestions. Obviously the source code of the gateway, we plan to open source it in a couple of weeks once it gets to the level of stability we want. So you can literally take that node, you can run it yourself, you can do whatever you want with it. Okay. So very quickly, either you do the easy way, you go to a dashboard, or the hard way, and I think we'll do the hard way because that's what we're here for. So essentially, you see here the first API request. This is the URL network.ambrosus.com. We have to create an account so that we can start sending requests to the gateway. So, and there are two steps essentially. The first one is you need to use your email because we don't want people to create just random accounts like that without having an email. And that's just in the first version. In the future, you'll be able to create all of that client side and super secure. Now to make it work, we make it easy and we use the gateway. The second step is, and well, you know what, I'll just show it and then I'll stop talking. So, who here has been using Postman? Who has never heard of Postman? Good. So Postman is basically one of the best applications for any web developer, and it allows you to very quickly send API requests. And you'll see how amazing it is in a few minutes. I've shared the list of API requests, so if you want to play around with, maybe the first thing I'll do is you can go to this URL here, which is bit.ly.com and BIOTS. So essentially, if you go here, you have two documents. You have one which is the PDF of the slides you've seen. The second one is just a Word or GDoc document that details a bit more what I've sent. And if you scroll to it, you have some source code that I will show later. But if you go here, you have this collection in Postman. And if you download that file, I see lots of people and lots of lovely pets connecting. And just saying, good. So you just get that, and you will have the same requests. And don't try to do all the requests while I do the demo, because it will stop working and you will all be disappointed. So take it easy. Good. So the first thing I'll do, if you take the first request you have here, I'm going to use my email and vladnet.biots@me.com. So the first thing you do, and let's hope internet works, because it's not always working. So apparently it's been working, and you can see here, I've sent my request. It took a lot of time because internet isn't that fast. Thanks, Swisscom. Yeah. And essentially what happens here is that I will get an email, and where is my email? So I'll get an email here, and iCloud here, and I'm getting here. So you get by email just a token like that. What you do with this token, this is, just to test that you're really you. What you do is you use the same vladnet.biots@me.com. Use the second request. It's again at accounts, and now use this token. And essentially, you send this request. Ta-da! So you have a 201 created, and you look in the body. So now, what happens here, essentially, is I've created an account on Ambrosus. This is the address of my account, so it's essentially an Ethereum address, but not a real one. You will not lose money, don't worry. So you can keep this address, and you will need to, the thing is, what's really important is that take those things down, because we'll never show you those numbers again. So if you don't remember it, then you can just recreate a new account. But essentially, you have two things here. One is the secret, which is my private key. Yeah, you can copy or delete it afterwards anyway. But that's a private key that allows me to sign APIs that I'm sending to Ambrosus, or because we're very friendly and we don't want you to play around too much with signing, we show you a very easy way to use it, but not a secure way. And that's very useful to do prototypes and play around and use Postman, but it's not how you should do a real application in production. And you'll see in a minute why. So before that disappears and we all get disappointed, I'll just go to my Visual Code. I'm going to save this here, okay? So now what I'm going to do, I'm going to take this secret. I'll go back to my Postman. And before going back to the Postman, I'll go back to my PowerPoint. So this was how you create an account. That's very much the basic thing. Now, great. Okay, what do you do with this account? Then we go back to the API. The first thing you can create on Ambrosus, and that's the most important data structure in Ambrosus, is what we call assets. And an asset is a unique physical or logical entity, something that plays a role in a supply chain that needs to be identified. So it needs to have a unique identifier, and you need a POE, so a proof of existence, that this asset existed with a certain amount of data at a specific time. Who didn't understand that sentence? Should I repeat it? You will see in a second. So what that can be essentially a container. It's an asset. You would have a purchase order. If someone sends an invoice, that's an asset. A box of medicine, a single individual box of medicine, that's an asset. It has a unique identity. Here you have a pallet with lots of boxes like this one, or a crate where you put fruits and so on. All those things become assets. And that's the most simple thing you can create in Ambrosus. So it's essentially a digital, unique, verifiable identity for something physical on the blockchain. Here, I mentioned before, you want to order this element here, so let's create it directly in the API. So the simplest way to do it is this. You would create a post, you send that to our gateway. Obviously, you need to give here the secret. That's the one you get and you didn't lose, of course, in the previous request. You would give it a name, you say essentially what it is. You need to give your address here and a creator here. And the reason you have both, it's essentially the two different accounts. They can be the same, but the reason you have two of them is, one, the owner is essentially the person who pays the bills. So it's the person who owns that piece of information. So if I'm the creator of this, then the owner is me as a company, but the creator, here, the creator is who has sent this request. So it's not always the same identifier. The reason is you want to put all those numbers here is because that content, what you're sending, is going to be signed. We're going to take this whole piece of information, sign it with the secret, oops, no. We're going to make a hash of all that information exactly as it was, and that's what we will put on a blockchain later on. So you can always prove that, yeah, the created at or the quantity didn't change. That's essentially what we've created. So I would say let's go right away and create our first asset. So if you go here, you have the container. Here, what I'm going to do is I'm going to put my secret here. Obviously, you shouldn't do that when you do a presentation. What? Oh, yeah. Good. Sorry. So I go back to Postman. Here, I'm going to put the secret I just got before. And I'm going to take the address here. That's the address of my account. Go back here and put it in the owner field. And put it in the creator field. And here I can add an image, I can add some identifiers. Identifiers can be a barcode, which makes sense in my business system, is anything that allows me to identify that specific box. The timestamp is just a Postman thing, but essentially we'll replace that when I send the request with the actual epoch timestamp. I'm sending this and I have a 201 created. Before we look into that, let me have some water. Do you have questions so far? Is that confusing? Is that easy? Good. So what you see is that I've sent two things. I've sent this element here called content. And that's essentially the entire amount of information I want to record. When I send that, what the gateway does is that it generates an ID. This is a globally unique ID that's going to be stored on Ambrosus network, and that allows me to identify this very unique instance of a product and that everyone else would not contest with. Now, the two elements you would see here is that the content element is exactly what I've sent. Nothing got added, nothing got changed, other than, of course, the created at, which was substituted when I sent the request. Now, what you see here is the signature field. And the signature is essentially a hash of this element signed with my secret. So what I've done is I've sent the secret to the server and say, hey, I don't want to sign it because it takes too much time. Can you just sign it for me? So the server got that data, sign it, only store the signature, added his own timestamp. So you can see if there is any disagreement of when, if I say it was created like in the future, the server could say, okay, so how come you created the future, but Ambrosus network received it in the past? So that's how you can detect some issues. Questions so far? Does that make sense? Good. Don't be shy. Yes?
Maybe just real quickly, what is exactly the importance of this in the greater scheme again?
Of what I'm showing here. So this is an asset, right? And an asset is essentially every company that works in the supply chain industry or in the food or in pharma, they have lots of assets. And an asset can be a box of medicine, that can be a pallet, that can be anything physical they need to track, they need to know where it is, they need to, that's the basics of traceability, right?
So when would this be created? When would this request be sent?
So you would create it, that's a good question. It really depends on different manufacturers. So if you look how some companies are doing it, they go on the production line and they write manually how many, if you go to a Nike factory somewhere, they will record manually and say, okay, I've created that many shoes at the end of the day, or they have some printers, and the printers who print the label inside your shoe, at the end of the day, they will generate a written Excel spreadsheet that say, hey, that's how many shoes we've generated today. It doesn't have unique IDs for shoes. Most products on the market, if you take pretty much any product on the market, unless like watches or expensive things, almost nothing has serial numbers. And if you take this bottle here, you know, if you take those two, okay, that's not the same product, but there's no unique identifier. So if I have 10 products like this one, the only information I have is at best a batch number. So I know when it was made, and I can go back and know what the batch belonged to and where the tea came from. But I wouldn't know the difference between this bottle and that bottle. Here it becomes very interesting because you can say, hey, every single product, every single bottle has a globally unique ID. So that means if I scan this bottle and let's say I play a game or a lottery or something where I win rewards by scanning this, that means if someone else copies the same barcode, no one else will be able to claim the reward again because you know, oh, hey, this bottle was supposed to be here in that place. So when it got created, obviously our vision is that we want every single printer, when they print a label, they would directly create that request. In practice, it's not always doable because the way the equipment on production line works isn't that real time. It's essentially at the end of the day, they take a log of what was printed that day, and finally they store that in Excel spreadsheet. But the problem of waiting for a whole day is that someone can go, and that's what happens a lot, someone would go and say, well, let me just add a few more and remove them, and you have this opportunity for people to snack in, as opposed to say, hey, there is no room for fiddling around. Pharma specifically, they want in 2 or 3 years that every single time you create a product or you do some tests, they will require you the information to be sent immediately. So you don't have a buffer of time where you collect that information, which is a point of failure that people can come. And this is exactly the assumption we're working with. We understand that in practice, not many companies are ready with the production lines, but the ideal case is every time a printer, they would directly send that to Amden and say, hey, I've printed this label, I've made this product, I've made this thing. Yeah?
Suppose I'm the manufacturer that range. So what do I need to know the difference between, if they come from the same batch, yeah, they get bottled from the same batch, exactly. So just think about the production line. What do I need to know? Because if I use a technology that creates a cost.
Of course.
Yeah, and an additional process. Okay, so what's the benefit? What do I need to, in this specific case, what do I actually need to know the difference between
this bottle or the other bottle?
This bottle, if they come from the same budget, it's actually
sure.
logical. It's impossible not to be different.
You're pretty much right. I think one thing you have to take into account is you have no way of knowing if I create 10,000 bottles in that batch and someone else create 10,000 more.
If it's a batch, if it's a 1,000 liters, then I know how many. It's very, very
yeah, what I'm saying is that if someone creates more, I'm talking counterfeit. So if I create additional ones with the same batch number, you don't know if it's a genuine or not. That's the point. So, of course, you say you are creating 1,000 of those, right? It's your batch of 1,000 and you're very happy. But I can take this product, copy it because there's just a batch number, and I create 100,000 of them, and then how come there are 100,000 on the market when I only created 1,000?
No, for designer clothes, yeah, I understand those socks and other products, but for food?
But that's one of the biggest problems, right, is counterfeiting. Lots of people create, one thing they do is they create fake products, and they say, yeah, it's real cheese from Switzerland, of course. And they sell it in China. It has never seen the Alps. So that's one of the real problems. The second problem around that is, let's say I buy this product, I drink it and refill it and reclose it, and that's another very huge problem that happens in China. Lots of alcoholic drinks, they basically sell 10 times more Bordeaux wine in China that has been produced. So that's kind of a big problem. And how do you track that? And oftentimes what happens is they take the drink, they empty it, have a good night, refill with some alternative, put the label back, and it's just a piece of plastic. There is no way of knowing. So if you have a unique identity around your product and you create some logic around it that say, hey, this product has been consumed, and this is something I'm not going to go too much in detail now, but we can go afterwards. I see the time is ticking. But essentially, that's really the point. Maybe we keep that discussion for afterwards.
One question would be, is there a particular reason that you chose to make the hash over the complete data rather than, for example, using a Merkle tree and so only saving then the Merkle root reduction?
So that's
only choose, let's say, one of the items rather than always just the whole.
Sure, that's a very good question. Essentially, the design we're currently implementing goes much more in the direction where we only store this piece of information, essentially, and we use a Merkle tree to store that. The current implementation you're going to be using, that piece of information is stored in a local MongoDB database. But the goal, what you want to do, and that's something we can also discuss later, is what you want a place where you store the entire information, but that place doesn't have to be the blockchain, it doesn't have to be distributed. You can put that object on IPFS, for example, and only store the important information, which is the metadata and the signature of that. So it's a very good question. And the current implementation you'll use doesn't have that, but the future is exactly where we're going. Any other technical questions? Good. So essentially the second element now is you have created an asset, and the thing you see here is that you have this information. Now what you can do is you can simply read that information here, and you would send the request, and you see exactly what has been created. Here, that means, as you can see, in the header, I didn't use any type of authentication. So that means anyone can go and query that information. It's essentially public. So you send this query, you just enter this URL, and you will see exactly the same thing. This is obviously not okay if the data is very internal, and that's exactly what we're working on the future version, where most of that data is actually internal, and only the hash is actually public, so you will not see the details. Now what you can do afterwards, you can create an order. So now imagine this, the second element, you have this box and you want to create a shipment that you want to monitor. So what I'm going to use is I go back to, I will create simply another asset. I'll create exactly what I've done here. No. So I'm going to create a second asset. And that asset represents an order. So it's not anymore the physical product, it's essentially the order, and I can add some fields here. For example, when it needs to be delivered, and here it's not a timestamp, it's just an ISO 8061. I can say the delivery place, which factory or which delivery point it has to be delivered, that the contents, and the contents, essentially I'll just go before, this is the ID of this box. And I'm going to essentially go here and say, okay, well, you need to ship this box here at this address, and the penalty for 24 hours of delay is 5%. And I can add the contract here. I just use a random template, but you can imagine taking the real contract, the physical printed contract, you put that on IPFS, and you store either a hash or directly the URL of that element. So you can see no one has modified the physical contract that's associated with it. And here you can also add things like a shipment ID. That's how you will be able to use it. So you create this other one. It was created. And here you see it's exactly what you've seen before. You have all that information down now that has been signed, so you cannot change the content without anyone noticing it. And now what you can do, if you look at here, no. Yes, so what you can do here is I've used this shipment ID here, AACC3344. Then you can, of course, find it by shipment, and you get exactly the same information that I've just created. Obviously, there are a few of them because I've played around a few times across different creators, but you can see some of them are created by the same account and others by my new account here. So now, if we go back here, the reason I was showing you this is that if you look how logistics essentially working is, it's very, very complex in the sense that you have graphs of information and things that are connected to each other. You might have a box, and that box connects to a bunch of assets, and every box, mini box like this of 4 products has 4 of them inside. So you can imagine from a company perspective, when you are Nestle, you have like thousands of type of products and billions of products throughout the world in all directions. That's a huge amount of information you need to keep track of. And the way it's done today is a bunch of different IT systems, one for manufacturing and one for manufacturing in that factory. It's really a huge mess. So if you're able to take all that information, use a data model like the one I've shown before, integrate all of that into one single place, and have as a side effect the ability to prove that data hasn't been changed using blockchain, then it becomes really interesting, because then you have metadata attached to each of those things, and you can do the second type of very important information, which is events. And that's the second most important thing you can create on Ambrosus. An event is essentially some important timestamp information about an asset that you want to record and proven after the asset has been created. So when you create your batch, and that comes to your question when you actually create it, you create your batch and you say, yeah, it was created at that factory at that time, production line number 4, and Mr. Joe is the one who did the quality control. But then afterwards, that product, that box is going to start moving, and you will need to change or add additional information about that thing. So imagine here I have a pallet. There are 8 boxes on it. Exactly this one, and there are essentially 8 cartons like this, each one filled with 40 times 460 plates of medicine times 8, it's almost 1,000 small things like this. So what happens is you would have a handheld scanner. That's a device that has a private key on it, so you will not send the secret like I've shown you in the API request before, but that device here can scan a product, and you have an asset here, the asset ID. You will send an event, and an event always has 5 pieces of information. The who is essentially who has signed that transaction is the creator. So it's essentially the handheld scanner. What? Well, what has been scanned, it's essentially this asset, where you always have a place ID that can also be an asset, your factory, your loading deck, and so on, when it has the timestamps, and why, there's always a why as well. Why was the product at that place at that time? Here it was passing through the customs, and you want to write this event, which is essentially saying, scanner saw a pallet and the temperature was 14 degrees. The principle is essentially very, very similar to what you've seen before. The main difference is that here you have a subject now. The subject is essentially the what. What is the asset ID that you've scanned? And the interesting thing is here you have scanned one asset, but that asset has thousands of products in each of them. So you don't want to create 1,000 events for every single box. You just create one on the major one, and then you use kind of graphs to find the relationship between products and retrieve the history of where that individual product was seen, was scanned by going up in the hierarchy. So here what's also interesting is you can create an event. We have 5 more minutes, so I'm not sure I'll get to the smart contract part. But essentially, you have the interesting thing when you create an event is you can also attach some information like temperature. Here, for example, it would be the average for the last 5 minutes, for example. It's not just at a single time, because if you write at a single time, you don't know what happened in between. So what you would do is you will have a device that records data continuously, and every few minutes or days or hours, depending on your use case, you would record that information and say, yeah, that was the temperature, that was the humidity. And then the second thing, which I wanted to show, but I'm not sure how far we'll be able to go, is you can use the events that are coming in. You can monitor them. You can use a smart contract that says, okay, as soon as a parameter has been exceeded, then you do something. You pay a penalty, or you do something that is essentially proving that the temperature has been exceeding. Do you have questions so far? So far, it's almost the end. So essentially, this was one of the use cases which becomes really interesting, and we have the source code of that, and it's kind of documented, so I'm more than happy to show you afterwards as well. But the thing, what you would do is you would create a smart contract that's out there. You would create in that smart contract what we call a shipment, and I can show you that in a minute. You ship the product, and then when you receive, you look if the smart contract was triggered, if there was an event, or if there was a temperature that exceeded. So if you go back to that URL, you can see here, that's essentially the source code of the application. And I'll try to be very, very quickly. What this app is essentially is 2 things. One is a Node.js web application that you can take and run on your laptop. That web application just takes data from devices. You can just write data to it. This is something you can run on a Raspberry Pi in a truck. That's something you can run in your data center. That's something you can run wherever you want. Here, the smart contract, just to make it easy, we're using test RPC, and a gentleman before, I think, showed that with Truffle and test RPC, how it works. It's just easier to do, but obviously the point is you want to use a main Ethereum network or something that you trust, and you deploy your contract there. So do we try to do it very, very, very quickly? So good, let's be ambitious. So if you take that thing, you just go in the main repository of the app. You just start npm start. Once you've started this, and before you do that, essentially what you will do is you go here and you would run your test RPC. And all of that is documented. So you run your local network, test RPC, you run your npm script, and essentially what's happening now is you would go to this place. So this is essentially the interface of the Node.js app. You have to give your owner and your secret. So I've fed this before, but essentially you're creating a shipment inside the smart contract. And if you look at the smart contract here, essentially you're giving some constraints, and you're saying, okay, this is the mean temperature, the max temperature, minimum humidity, max humidity, air pressure that your thing is going to go through. I'm not going to go into details because it won't work, but essentially you have a contract here. 1 minute. Okay, excellent. Well, we can do it. So essentially what you're doing is you create your shipment, you create your temperature, and you have your okay. That's creating essentially here, if you go to the RPC, you see that there was a transaction which was created here, which is the shipment. The second thing you do is you create an event, and this is the second request. You're creating an event where you say, okay, the temperature is 10. In this other one, you see that the maximum temperature was supposed to be 5, and then you look at the status of your shipment, and there was a problem with it. Okay, it's not very impressive because I had 1 minute, but I still managed to do the whole thing, and the code is there. So, any questions? I think that was dense.
30 seconds.
Who agrees it was very easy? Sorry. Yeah.
Well, this way you will, it's for the end user to see if there hasn't been any problem in that shipment.
In this one?
Yeah.
You can use both, yeah. It can be both the end user or the company who is receiving.
The company could also data mine it, and you see that switch rule, for example, like chocolate, it could extract that information and then use it also, right?
This is designed really for the company first. So it's designed for manufacturer and importer. They have that data. And then, for example, if you're a Chinese company and you import chocolate from Switzerland, you can use that technology to prove not only the chocolate really came from this place in Switzerland, this factory, but it was also conserved at the right temperature. It didn't melt on a boat somewhere in
But could you also look at the customers and data mine the customers, for example?
Sure. I mean, here what I've done is just accessing a URL. So you can imagine instead of having a URL, it's just a very nice web app which says scan this product. Every time someone scans it, you also can create an event and you can use that information.